Hey, this is Mrs. Leonard. We're going to go through each of these questions together. So let's go ahead and begin. So question 1 through 3 are based on these outcrops, these different rock layers. And it even tells you that there is no overturning. It tells you that there's an unconformity, which is an erosion of a rock layer. And this right here tells you that that's the unconformity, just so you know that what that is. We haven't talked about that yet. And the first question says to correlate the rock layers between outcrops A, B, and C. So the easiest way for me is to look for similarities, right? Correlate means to match them up. And so the first thing that I see on here is this volcanic ash. And I can see that it's in outcrop A, correlates with outcrop B up there, and it correlates with outcrop C over there. And that's a really great way to see those rock layers and see how they match up, because then I can look below that and I can see that this green shale here matches up with this one and this one as well. So I just draw a line connecting the bottom of those layers, and then I can see that the green siltstone, the gray siltstone, also matches up with all of those. And that helps me to correlate or match them up, right? And then I can also see above that is the tan limestone that matches up or correlates between A, B, and C, and also the conglomerate. And I think that is as far as I can go for outcrop B, but hopefully you can see that, I'm going to change my color here. Hopefully you can see that the brown sandstone also correlates over here from outcrop C over to outcrop A. Hopefully you can see that, okay? And then hopefully you can also see that below in outcrop C, the red sandstone correlates with the red sandstone in outcrop B, and I'm going to change the color again. The gray limestone correlates with the gray limestone in rock outcrops C and B. So hopefully you can see that. So now we're going to go on to question number 2. So question number 2 says, which rock layer is the youngest in this area? So when we're looking at the youngest, we should be looking at the top, right? Because remember, the oldest is on the bottom, the youngest would be on the top. So if I look at all of these outcrops, I'm going to have to figure out which one is the youngest. And of course, there are 3 possibilities if you're looking at all 3 outcrops, but because we have correlated all of these, we know that that absolute youngest rock layer can't be conglomerate, because the conglomerate isn't the youngest rock layer in outcrop A. And it can't be the brown sandstone in outcrop C, because that is not the youngest one in outcrop A. It has to be for all of them. So the best answer, I think, is tan siltstone, because that is the absolute top layer in all of these rock outcrops. So when we come down here, we see that tan siltstone is an answer choice. Number 3, which particular rock layer or event helped you easily correlate these outcrops? I mean, this is your choice. As long as they all match up, it doesn't really matter. I always find it easier to look for the one that stands out, and to me, the volcanic ash stood out. But to you, it might have been another one, and that is fine. Okay, here is the next set of questions. Questions 4 through 7 are based on the locations below. The numbers represent fossils within the rock layers. So each of these numbers is a fossil. There's an igneous intrusion at location C. Right, so here's location C. Yes, here's the igneous intrusion right here. An unconformity is an erosion of a rock layer, right? We've got a couple of unconformities here and here. And the layers have not been overturned. That just tells us that we know that the oldest rocks must be on the bottom, okay? Our law of superposition will stand for that. All right, question number 4 says, what is an index fossil? So for that, you had to look at your notes, and what you should have discovered is that index fossils lived over like a wide or a large geographic area, right? So these are fossils or organisms that lived over a really wide area, like in a lot of places, not just like in New York City, for example. They lived like all across New York State or all across the country, or best index fossils lived all over the world. So you know that when you find this index fossil, oh, this is a fossil that's going to tell you like the age of that rock. And then the other thing that has to be true is that they had to live for a short time, right? Because if they lived for a really long time, because the whole point of an index fossil is that it's going to help you figure out exactly how old a rock layer is. So if you find that index fossil, if you find that fossil, you're like, oh my gosh, I found this little trilobite, right? It's a very specific trilobite or a dinosaur bone. And so it's going to tell you exactly how old that rock layer is. And because you can find them all over the place, it's a really great way to communicate with other people. Like, oh, did you find that fossil? Yeah. Oh, then we know exactly how old that rock layer is, because those organisms only lived for a tiny amount of time. Well, when I say tiny amount of time, I mean it might have only been 1,000,000 years. In geologic time, 1,000,000 years is a really long time, or is a really short period of time, okay? Because, Earth is 4.6 billion years old. So that's the kind of thing that we are looking for, a large area and a short time. So a large area would be like all of these, right? If it lived in all of the locations, like if we find that fossil in location A, B, C, and D, then that's a good index fossil, as long as it lived also for a short time. Now, a short period of time would mean, I only find it maybe in one rock layer in location A, right? If I find it in a lot of rock layers, 2 or 3 rock layers in location A, that's a lot longer time, right? Because it lived for this amount of time while this rock layer was being deposited, and it lived for a long time while this rock layer was being deposited. So if it's only for one rock layer of deposition, then we know that's a short period of time. Okay, so question number 5, which numbered fossil would make the best index fossil? Oh, so we're looking for something that's going to show up in all of the locations, but maybe only in one rock layer in each location. So if we go through each of these, number 7, we see that it shows up here, here, here in location C, and here in location D. Seems like that would be a good choice, right? But I'm not going to stop there. I'm going to just make sure that all of my other answers don't make sense. So number 10, I see here. I'm going to use a different color for that, actually. Here. Oh, I don't see it in B or C. I see it in D. Oh, so nope. Number 10, fossil 10, sorry, you're out. You are not a good index fossil. Fossil number 3, use a different color, is here in location A and in location C. Oh, no, that's it. And so that is not a large area. Sorry, fossil 3, you are not a good index fossil. Number 4, same thing, I think. Yeah, yep, it's only found in location B from what I can see. So yeah, location fossil 4, not a good index fossil. So looks like answer choice 1, number 7, index fossil 7 is the best answer choice, the best index fossil. All right, number 6. How do you know that the igneous intrusion is younger than rock layer 1? So here's rock layer 1 right here. And this is that igneous intrusion. How do we know that that igneous intrusion is younger? Well, it's cutting through it, right? Remember, our law of cross-cutting relationships tells us that anything that cuts through a rock layer must be younger than the rock that it's intruding into. Is it started off down here as some magma probably deep below ground, and then it worked its way up and finally erupted on the surface as this volcano. So the rock layer 1 has to be older because the intrusion cuts across rock layer 1. That's all you got to say. Okay, that's the evidence. All right, number 7. Which rock is likely forming on top of rock layer 1? Oh, we said that it was a volcano, and we know that volcanic rocks are also extrusive rocks. Remember that from our igneous rock chart? And so you would have to look at your igneous rock chart and find which rocks in this list are extrusive. And if you do that, you will see that sandstone is a sedimentary rock, so that's not going to work because it's not even an igneous rock. We see that gabbro and granite, those are both intrusive rocks, so that's not going to work. So it's got to be basalt. And if we look up basalt, basalt is the only one that is extrusive. Okay. Next page. In what time period do we see the earliest insects? So earliest insects and time period. And for that, I am going to have to go to my trusty Earth Science reference tables. This is pages 8 and 9. in my Earth Science reference tables, my BFF, and I'm going to have to look at life on Earth, this life on Earth column right here. Okay, now I'm going to switch to a color copy because, as you can see as I'm zooming in, this is kind of blurry. So this is my color-coded copy, and you can see that the life on Earth column is right here. And so we have to look for earliest insects. And so you just kind of scroll down here and you just kind of look, and you're looking for earliest insects. Wow, so it's like insects have been around for a long time because we have to go back in time quite a ways for us to find earliest insects. Aha! Here's our earliest insects. And when we look here, we see that it's happening in the Silurian time period. How do I know that's the time period? Well, if I scroll up, it tells me right here that that's time periods, and these are the epochs, right? And the question was asking which time period and which epoch. And so if I go back down here to my earliest insects, then I should be able to see here, the time period is the Silurian, and it is the late Silurian because it's up here at the top, okay? So when I go back to my sheet, I see that I'm going to write late Silurian. All right. Question number 9. In which era do we find the earliest dinosaurs? So once again, I'm going to go to my awesome little color copy here of my reference tables, and I'm once again going to look at this life on Earth, and I'm going to find the earliest dinosaurs. So I have to, let me zoom in a little bit so we can see this a little bit better, and I'm going to zoom and look until I find earliest dinosaurs. Oh, here's abundant dinosaurs. That means there's a lot of them. Aha, earliest dinosaurs. Looks like it's happening here in the Triassic time period, but the question was asking me for the era. So I have to figure out what era that took place in. And so if I find earliest dinosaurs here, Triassic, and the color coding helps me on this one because all of the time periods that are in yellow here are part of the Mesozoic era. All of the ones that are in red are in the Cenozoic era, and all the ones that are in green are the Paleozoic era. So color coding kind of helps. If you want to color code your chart, you could use some colored pencils or crayons to do that. It's not a bad idea. So if we come back to our sheet, era, we found the earliest dinosaurs. That was the Mesozoic. So let's go on to number 10. In what epoch or time period do we find mammal-like reptiles? So we're looking for mammal-like reptiles this time. Okay, so once again, we're looking at the life on Earth column, and we're looking for earliest mammal-like reptiles. Well, here's mammals, but that's not mammal-like reptiles. Oh, earliest mammals. There we go, mammal-like reptiles. And I'm seeing that here in the middle Permian, which is in the Paleozoic era. But the question was asking us for the time period and the epoch. So, and a lot of times they might just say, what is the epoch? You would actually, for the epoch, you would actually say late Permian. You actually would put those two together. But I was helping you out by telling you to put both of them. So let's go back to our question. And now we know that that would have been the early Permian. All right, question number 11. How many millions of years ago did Earth have extensive coal-forming forests? So this is asking me for millions of years ago, so I'm going to be putting numbers here. So extensive coal-forming forests. Let's take a look. So once again, I'm looking at life on Earth, and I'm looking for extensive coal-forming forests. So these would be forests that have a lot of swamps in them. Oh, I went right by it, didn't I? Extensive coal-forming forests. So these are forests that had a lot of swamps in them. And so when those swamps, when all of those plants died and they fell to the bottom of the forest floor, they created over years and years and years of piling up of more sediments on top of them. You ended up with coal forming. And again, we're looking for the number of years. So these numbers here are what we're looking at. And you can see up at the top that these are millions of years ago, right? And so it would be in between 299 and 318 million years ago. So when I come back here, I said 299 to 314 million years ago. I think that was right. Just gonna double check my key. Nope, I was wrong. 318. You knew that. Good job if you caught my mistake. So 318. I'm even gonna erase and just fix that because that's gonna bother me. 318. Okay, so let's go on to the next one. Number 12. Which species went extinct? That means that the whole entire species just died out. They don't exist anymore at the end of the Paleozoic era. All right, let's take a look. So this time we have to look at the eras column, right? We're looking for the end of the Paleozoic era. Now, this is tricky, right? Because if we think about time and we think about the end, are we talking about the end being here? Or are we talking about the end being at the bottom down here? So remember, time starts at the bottom, right? The oldest rocks are at the bottom. So this is the thing that happened first, right? All of these things down here happened first, and then time goes on. So technically speaking, this up here is the end of the Paleozoic era. This is the beginning of the Mesozoic era, and then the end of the Mesozoic era would be right here. So if we're finding the end of the Paleozoic era, the mass extinction of many land and marine organisms, including trilobites, that is what we're looking for. All right, so we said at the end of the Paleozoic era was, you could say all of that, but we were looking for just one particular species, so I was going to just say trilobites. But if you said many marine and land living organisms, that's fine. That is perfectly awesome, okay? Number 13, in what time period do we find the species Phacops? All right, let's go to our reference tables. All right, so for this one, they're giving you a very specific species. And when they give you a very specific species like that, they're probably talking about these species that are at the bottom here where all of our lovely little index fossils are. So we would have to look down here to try to find that specific species. And if I look at all of their names, I see right here is Phacops. It's a trilobite. It's actually a trilobite that is very common in Ohio, where I grew up. We would find these all over the place. So what we're going to do is we're going to look for this letter C in our reference tables sheet here. And if we go over here, we see that there are a bunch of, I think I'm going to go like this. We see that there are a bunch of letters over here, and A, B, here's C. So these are all trilobites. So you don't even have to know that that's what they're called. A, B, and C are all trilobites. F and E are organisms called nautiloids. They're ammonoids, crinoids, dinosaurs, mammals, birds. They're all labeled here so that you know exactly what all of these organisms are. And then the letters correspond to all of the index fossils, specific species of organisms down below. So Phacops, we wanted to know during which time period these existed. And if you look all the way over to the left, we know that it was during the Devonian. So, Devonian, because that is our time period. Great. Number 14, during which period, so this again is a time period, can New York State be found south of Earth's equator? Notice that I'm annotating each of these questions too. This is to slow my brain down so that I don't miss any important details. You should be doing the same thing. So south of the equator, we're trying to find the time period that New York State can be found. All right, let's find that in the reference tables. So for this one, we are looking at the inferred positions of Earth's land masses. So this is telling us where all of these different like continents used to be before plate tectonics started moving them around. So this is a little closer to what it looks like currently. This is what Earth looked like about 59 million years ago. This is the North America. So this is Canada up here. This is Mexico right here. Here's Florida. And so we are right on the East Coast, probably right about here. So I think of us as like halfway between Florida and this little part that sticks out up here. So like right about here. And the equator is right here. This is the equator. So we're trying to find things that are south, when New York is south of the equator. Currently we are right there, so we are not south of the equator. So we have to look at this until, we have to look at each of these pictures until we see New York is south of this equator line. So that's not it. We're getting closer, right? So remember, this is where we were a long time ago, and we have been moving north of the equator. So a long time ago, we were actually at the equator, probably right about here. We're close to the equator here. We're actually a little south of the equator here. So I would say anywhere before 359 million years ago. So any of these time periods here, so we would have to zoom over here a little bit, right? So we said any of these would be great, right? So starting with Devonian or Silurian or Ordovician or Cambrian, any of those. If you said any of those answers, you got it. Nice job. And let's write that here. We found that was the Silurian time period. Or you could have said Devonian. Really, any of those would have worked, right? Cambrian, Ordovician. So any of those are fine. You don't have to write all of them. Just one of them is fine, as long as you understand that all of those are possible answers, okay? I think probably Silurian, Cambrian, and Ordovician were the best answers. Devonian, maybe. Okay, so next question. Number 15. For which segment of the Earth's geologic history are fossils rarely found? All right, let's take a look. Okay, so here we are at our reference tables. And really, if you remember, I had mentioned that all of the part that is in green, yellow, and red, all of these, this is all of our fossils on our planet, right? There's a huge, we call it a explosion of life starting about 542 million years ago. Prior to that, all we have are soft-bodied, our first multicellular soft-bodied organisms. There's not a lot of life prior to this Cambrian time period, but there's tons and tons of fossils in the Cenozoic, the Mesozoic, the Paleozoic. But once you get down here, there's just not a lot. I mean, you can even see, like, we don't have a lot of stuff that we're telling you about here. And this is almost like 1,400 years, 1,400 million years. That's a lot of time. And we call that time period the pre-Cambrian time period because it's before Cambrian, pre-Cambrian time period. So let's go back to our worksheet. And we can see that it's not Cenozoic, it's not Mesozoic, it's not Paleozoic, it's definitely Precambrian. Okay, number 16, which fossil would most likely be found in late Ordovician bedrock in New York State? So we're going to have to look at each one of these fossils and figure out if it survived, if it lived during the late Ordovician. Let's take a look. And yeah, so Cenozoic, nope. Mesozoic, nope. Paleozoic, nope. Precambrian is the correct answer choice. Number 16, which fossil would most likely be found in late Ordovician bedrock in New York State? So we're going to have to find each of these fossils and then see whether or not those organisms, those fossils, could be found in late Ordovician bedrock. So let's go to our reference tables and take a look. Okay, so for this, we have to find our little organisms all the way down here at the bottom of our Earth Science reference tables. So the first one, answer 1, is this guy. He's a dinosaur, Coleophysis, and this is letter L. So what I'm going to do is I'm going to find letter L. There it is. He is a dinosaur. That's what that bar tells us. And then I just follow it straight over and see, is that the Ordovician? No, that's Triassic. Bet you didn't know the dinosaurs lived in the Triassic. You thought they only lived in the Jurassic, didn't you? From the Jurassic Park movie. Ha ha ha. So Triassic, that is not a possible answer. Okay, so let's go to the second answer, which is this little guy right here. This is Dicelograptus. Yes, I don't even know how to pronounce these sometimes. That's okay. And that is letter K. So let's look at K. Aha, this is a graptolite. Graptolites are these little critters that they're very simple, as you can see. They're not very complicated at all. And you find them a lot in swampy kind of areas. And so K, if we follow that straight over, that is, oh my gosh, look, late Ordovician. I think we have our answer, but we're not going to stop there. We're just going to double check and make sure the others aren't found there and make sure we've got it correct. Number 3 is this little guy right here, our Elliptocephalia, and that is letter A. And letter A is found in the middle to early to middle Cambrian. Nope, that's not it. And then our last one is the beluga whale, which is letter O. And for that one, I have to go up here a little bit, and because it's all the way at the top of our reference tables. And nope, that is definitely not in the Ordovician. It's Quaternary. So let's go back to our question. All right, so now we know that it was definitely this one. All right, number 17. Scientists infer that oxygen in Earth's atmosphere did not exist in large quantities until after these different options. All right, so before I do this and look at all of these possible answers, I'm going to see if I can find when there was oxygen in Earth's atmosphere. Like, I want to find out when that actually started, and then I can figure out the answer to these other things. Okay, so erase that a little bit. Okay, so if I'm looking at oxygen in the Earth, it's probably going to be over here, and I know that because oxygen is one of the very first things that happened before. Like, we couldn't have a lot of life on Earth until we had oxygen on our planet. So when I am looking at that, I have to look for in this time scale, like the geologic time scale of Earth. And I see oldest microfossils. I see oxygen produced by cyanobacteria combines with iron. So it looks like this is when it first started. And then the oceanic oxygen begins to enter the atmosphere. So I would say this is when it first starts to enter, and then it's probably going to, you're going to have larger amounts as we get into this time period. So sometime after this, like 2 billion years ago, right? So now what I have to do is I need to go back to my answer choices and see which one of these happens after that time period. Wait a minute, I think I confused myself, because this says scientific oxygen did not exist in large quantities until after this date. So I'm trying to find, okay, this is a little bit confusing in terms of its wording, am I right? So I'm trying to find something. If we're talking about 2 billion years ago, I'm trying to find something that happened before that, because what we're saying is that oxygen didn't exist until after whatever this happened. So most of these things are probably happening after this 2.0 billion years ago mark, right? So we're trying to find something that happened before that, because all of these other things would have happened after, right? Okay, so let's see. When did this first one happen? The first multicellular, soft-bodied marine organisms those first appeared on Earth. We got to find out when each of these things occurred, and then we'll know what our answer is. All right, so let's go back to our reference tables again. Okay, so the first multicellular organisms, I believe that's like a pretty old thing, right? So the first multicellular organisms, here we go. First multicellular soft-bodied marine organisms. So that was 580 million years ago, right? Okay. And now we're going to look at the other ones. The second one was the initial opening of the Atlantic Ocean. So for that one, if we're looking at things that happen to land masses or, oceans, then it's probably over here in our inferred positions of Earth's land masses. So the opening of the ocean means that there wasn't an Atlantic Ocean to begin with, and now it's going to open up, right? And so you could look over here. There's also, it also tells you that in the important geologic events in New York. If we zoom in a little bit, we should be able to find exactly that statement in here, right here. Initial opening of the Atlantic Ocean. And so if I follow that all the way over to the left, it will tell me when that occurred. So I follow that all the way over. So sometime between 146 and 200 million years ago, or in other words, during the Jurassic time period, okay? So the Jurassic time period right there. So we've got our answer for that one. And then number 3 is the first sexually reproducing organisms appeared on Earth. So I'm going to have to find that probably here in our Life on Earth column right here. First sexually reproducing organisms. Where is that? Well, these things are all sexually reproducing. Fishes definitely sexually reproduce. So maybe it's before that even, which means it's probably in this purple part, the Precambrian. Ah, there it is. First sexually reproducing organisms. So that's during the middle Proterozoic. Okay. Seems to me like so far all of these things have taken place, right? The oceanic has taken place before all of these things. Again, we're trying to find something that this takes place after, right? So I'm hoping that the last one is right. Let's see. Photosynthetic cyanobacteria evolved in Earth's oceans. Where's that? It must be back here. There it is. Cyanobacteria are in our oceans. So it seems to me like number 4 must be the correct answer. So there we go. Because all of these things happened, this Earth's atmosphere, the oxygen in Earth's atmosphere, all of that happened before all of these things happened. Whereas this one happened, after, it happened after this one. Sorry, hope that was clear. Okay, number 18. You are a rock star for sticking through all of this. I know that this is a lot of work. I'm so proud of you. So number 18 says, during which geologic epoch do scientists infer that the earliest grasses first appeared on Earth? So again, we go to our reference tables. And for this one, again, we're looking at life on Earth. We just have to look until we find earliest grasses. Earliest grasses. There they are, way at the top. Earliest grasses. And it looks like we're looking for the epoch, and so that would be this column, and it looks like it's the Oligocene right there. So there we go. Oligocene. Easy peasy. You're probably getting really good at this. Number 19. The existence of which group of organisms spans the shortest geologic time? So we're going to have to go through each of these and just figure out which one seems to have lived the shortest time period. All right. Okay. So first up is birds. Earliest birds we're all the way back around 146, so that's probably like what, maybe 150 million years ago. And birds still exist. So we know that that's a span of at least 150 million years. All right. Dinosaurs. Dinosaurs, the earliest of them started right here, earliest dinosaurs. So that's halfway between 200 and 251 is about 225. And they went extinct, mass extinction of dinosaurs right here, which was 65 million years ago. So 225 minus, 65. Let's do that math here. That's 1. We're going to have to do that. Carry the 1. That's 5. So it's about 50. Oh, I should have known that. No. Is that right? Yeah. So that's about 50 million years. Ooh, that's a little shorter. So we know it's not birds. It could be dinosaurs. Let's keep going. Humans are way up here. Humans only have been around for about 1 million years. So, I think that our lovely humans are probably the winners at this point. And then let's just double check. Placoderm fish. So placoderms, you have to look over here on the right hand side to try to find the placoderm fishies. And if we look all the way down here, we see the placoderm fish here. They started off right down here, about 400, I don't know, we'll say like maybe 420 million years ago. And they died, their whole entire species died 359 million years ago. And so if we do the math, let's see, that's a 1, the 1, so that's going to be about 61 million years that they survived. But I mean, that certainly does not at all come close to humans. Humans are the shortest lifespan. So the correct answer, humans. Okay. Number 20, the geologic timeline below represents the 3 most recent geologic eras. The numbers represent events in Earth's history. Which number best represents when humans are inferred to have first appeared on Earth? So we just looked at this and we noticed that it was all the way at the top of our time scale, right? And if we look, and we'll take a look at the reference tables, it should be number 4. Because the Paleozoic is a long time ago, Mesozoic is middle time ago, Cenozoic, Ceno actually means new. It's the newest time era. But we'll take a look. Yep, here's the humans all the way up here at the top of the Cenozoic, right? So number 4 makes the most sense. So number 4. Last one, number 21. The cross-section below shows rock layers A, B, C, D, and fault F. The rock layers have not been overturned. Which sequence places the rock layers in fault in the correct order from oldest to youngest? Remember, oldest has to be on the bottom. The youngest should be at the top. And we've got a fault. Remember, faults are always younger. Than the surrounding rock, right? So remember, the rocks have to be there in order for them to be cut or cracked by that fault. So that means that this fault probably is last, right? It's probably the youngest thing that happened because it's cutting across all of those other rock layers and it's affecting them. You can see that this side has moved up or maybe this side has moved down. So I know that's probably the last thing that happened. And then I can kind of work my way backwards from there and just take a look at the law of superposition to help me figure out what happened to the other ones. D is on the bottom, so it's probably the oldest. And then as we go up, those are probably younger than that. So the only one that seems to fit, because it definitely can't be number 3 or 4, because F is first, that can't be. And D, we know has to be the oldest, so I'm guessing it's got to be number 1. Yeah, because I know A was definitely not deposited first, right? So that can't be it. So number 1 is the answer. I hope that this helped you, and I'm excited to see how you do on the benchmark tomorrow. Good luck!